Good afternoon, students. Today we shall be looking at redox. And what do we mean by the redox? Redox involve two terms abbreviated together. So we have reduction, that's RED, and OX means oxidation. So that is what I just highlighted here. So we have this and this. Does that make sense? Now we have, what are we looking at actually today? We are looking at how to balance redox equations. And redox equation will come in two aspects, in two forms: the complex form and the simple form. And don't forget that redox equations are ionic equations. In other words, when you have them to be balanced, or before you have them to be balanced, it must be in form of an ion. Probably the ion is a radical or a normal ion. Do you get it now? But it must possess an electric charge, whether positive or negative. Does that make sense? In the case of probably you are giving a compound, let's assume you have FeSO4, that's iron sulfate for instance, and you have another compound that you are to use to do the half cell equations. What you just need to do is to separate the ion from the sulfate. That Fe, you have Fe2 plus and SO4 2 minus. But we are not going there today. Does that make sense? We have not started picking questions. When you see questions, you know how to apply the knowledge. But the first thing to do today is to know how to balance the question given to you. So, how will I identify if the question is complex or if the question is a simple ionic equation? So in a nutshell, we have ionic equations. Ionic equations are redox equations, or redox equation come in an ionic form. That's what I mean. So it can either be simple or it is complex. So when it is simple, how will I know? When it is lacking the presence of oxygen, it is a simple equation. When there is presence of oxygen there, it will be a complex equation. So when it is complex, what are the question they can ask regarding that? Do you get it now? So they can either ask you to balance it in acidic medium, or they ask you to balance it in alkaline medium. So these are the two methods of balancing complex ionic equation. And don't forget that complex ionic equation, there must be presence of oxygen there. Does that make sense? So if that is the case, can we have a question under simple ionic equation? So I have, the first question says, balance the following reaction by half cell method. So half cell method involves dividing the equation given into two half cells, which involves the oxidation half cell and the reduction half cell. So how can I divide this into two half cells? This is a question. Sodium plus hydrogen ion to give sodium ion plus hydrogen gas, H2, into bracket of G. This is G. That's the state of hydrogen. So I'll pick sodium to sodium. That's sodium to this sodium. The charge of sodium here, from the question you are saying nothing. Hence the charge will be 0. Does that make sense? The charge of sodium here is positive, and the positive is representing +1. Does that make sense? So I have the second half cell equation. I have hydrogen to hydrogen, but that one is hydrogen gas. Does that make sense? So I have H plus aqueous to give what? Hydrogen gas. Now, how will I identify the oxidation process and the reduction process? The oxidation process, according to electron transfer, oxidation is defined as the loss of electron, and reduction is defined as the gain of electron. So when will I know an element is losing electron so that I can identify it as oxidation. When will I also know if an element is gaining electron, so that I can identify it as what? Reduction. Does that make sense? So I can only know when I observe that there is an increase in value. If, for instance, I have 0, so the charge here is 0, 0 to what? Plus 1. Do you get that now? So there is an increase in value, which tells me that it is losing electron. That's a loss of electron. Does that make sense? Hence, I will identify it as what? Oxidation. Oxidation half. Oxidation, this is my oxidation half cell. Does that make sense? So here, what does that mean? This is plus 1 to 0. It has no charge. Does that make sense? So it is, the value is reducing. Hence, it is reduction. Reduction half cell. So when the value is reducing, we assume that the element is showing the tendency to gain an electron, or has probably gained 1 or 2 electrons depending on the value you have. Does that make sense? So if that is the case, what is the next thing I will watch out for? I will try as much as possible to balance the atoms. The atoms. So the atom, don't confuse the atom with the charge. The charge has nothing to do with the atom for now. So the atom is telling you, how many sodium do I have here? So how will I identify the number of atoms here? The number of atoms here is just 1. How? This sodium is having an invisible number of 1 here. It's also having, for subscripts now, it's having an invisible number of 1. So I will calculate the number of atoms here by multiplying these two numbers to get the number of sodium here. That will give me 1 sodium. So here too, don't forget you are not dealing with the charge. Here too you have 1 invisible 1 here. 1 times that 1, which is invisible, is still 1. Hence, this sodium, the oxidation half cell, has no problem, or have no problem with balancing of the atoms. So let's look at that of hydrogen now. Hydrogen is having invisible 1. With an invisible 1, 1 times 1 will give you 1 atom of hydrogen. But in this case, we have 2 atoms of hydrogen. So which tells us that there is an invisible 1 here. 1 times 2 is telling me 2 here. So there is a problem there. This one is 1, this one is 2. So I must look for a way to balance this side to be 2 also. So how will I do that? How will I do that? I cannot edit this part of it. I will just put 2 here. That will make hydrogen to be 2. Hence, atomically, the 2 are balanced. So the next thing I will do is that I want to balance it ionically. So ionically now, the ions, that's the ion here, is plus 1. The ion here is 0. So I want to ensure that this place 2 is, this reactant side is plus 1 too. Or you can also decide to reduce this part to be 0 if you like. Do you get that now? But what I will be picking today is, I would like to balance it from here to make this to be plus 1, plus 1. So how will I introduce the electron then? Don't forget that the symbol of an electron, from SS1 you have been taught the structure of an atom, where you have the nucleus, which contains proton plus what? Neutron, and you have the electron revolving. This is the symbol for electron. Does that make sense? So I would try as much as possible to add an electron so that I will have positive 1. But then, have I added electron actually? No, I have not. I have just subtracted an electron. But I needed to what? Add an electron there. So how did I know that I have subtracted an electron instead of adding? Minus times plus. This is an invisible one, right? Minus times plus 1 will give me minus 1. Hence, I have subtracted an electron. So what will I do? I can decide to change this sign to what? Negative. Changing it to negative, I'll have minus times minus will give me plus. Hence, this side, we have 0 here. 0 plus 1 will give me 1. That's for charge. Here is plus 1 already. Hence, it is ionically and atomically what? Balanced. For the oxidation half cell. Does that make sense? So, can I try for the other one ionically now? Ionically, how am I going to do that? Plus 1 is here. Plus 1, this plus 1, I have to multiply it with this 2 here. That's the coefficient of hydrogen ion, hydrogen plus, to get plus 2. Right? I did the same thing here, but I didn't just mention it. 0 times invisible 1 here will still give you 0. Do you get it now? So here I have plus 1 times 2 will give me plus 2. This side is purely 0 because that's no charge. Does that make sense? So how can I increase the number of electrons here? Or by decreasing. So I want to increase here so that I can have the question, the two sides, that both the reactant side and the oxidation, that's the product side, balanced ionically. So what would I do? I would try as much as possible to add 2 electrons. 2 electrons. I'll try to add what? 2 electrons. Now, this one is plus 2. This one is what? Minus times plus 2 will give you minus 2. I have not added. Hence, I have to change the sign to what? Minus. So, minus times minus 2 will give me plus 2. Hence, the two sides, 0 plus 2 will give you plus 2 at the end of the day, and plus 2 here. These two sides are ionically what? Balanced. Does that make sense? So, what will now be my next step? Just take off the charges so that your work will not be rough. Does that make sense? So, what will be my next thing to do? The next thing I just have to do is to multiply the first, that's the oxidation half, by the coefficient of electron here, and to multiply the reduction half by the coefficient of electron of the oxidation half cell. These are the two things I just have to do. So let's go. We have Na minus 1E minus to give you sodium aqueous. So I'm multiplying this equation, right? So I'm multiplying this by the coefficient of this equation by this coefficient, which is 2. I don't need to consider the sign. Do you get that? So I have the second part, I'll have 2H plus aqueous to give me hydrogen gas minus 2E minus times what is the coefficient of electron for the oxidation times 1. In other words, we are just swapping the electrons when we are multiplying. Do you get that? So what will I get for this? For the oxidation half, I'll have 2Na solid minus 2. The 2 is affecting everything. It's affecting everything. So minus 2 to have 2 sodium plus aqueous E minus, right? So then I have the other part, I have 2, I multiply by 1 plus aqueous to give you H2 gas minus 2E minus. So let me call this my equation 1, this my equation 2, this my equation 3, this my equation what? 4. Does that make sense? So what will be the next thing I am to do? I am through with the work. I will just add up the two equations. So I will have add equation 3 and equation what? 4. So I'm adding up. So what will I add? Now, if you are adding up, be careful. You have to add up the reactant side of this and this together. Do you hear that? So I have sodium, 2 sodium, I have solid, minus 2E minus. I'm adding this. That's the reduction now. I have plus 2H plus aqueous to give, I'm moving to the product side, 2Na plus aqueous plus H2 gas minus 2E minus. Does that make sense? So if I will do anything here, I will cancel this and this. It's just like you bringing this here. Passing through this arrow will change it to plus, hence it will still cancel. Do you get that now? So what do you have? 2Na solid plus 2H plus aqueous to give 2Na plus aqueous plus H2. You have the gas. So having done this, I will have what? I will check it atomically and ionically. If it is balanced atomically and it is not balanced ionically, you are wrong. So probably you check through again and see where the fault is coming from. If it's also balanced ionically without being balanced atomically, it is still wrong. You have to check your solids again and correct that if need be. Does that make sense? So I have 2 sodium. I want to compare now, atomically now. I'm not going ionically. 2 sodium, 2 sodium. These are the atoms. Forget about the charge. The charge is not there. 2 sodium, 2 sodium. 2 hydrogen, 2 hydrogen. Hence, it is atomically balanced. Now, ionically, I have the charge of this is 0. So 0 times 2 will give me 0. The charge of this is plus. Plus times 2 is what? Plus 2. This is plus. Plus 1 times 2 will give us what? Plus 2. The charge of this has no charge, hence it is 0. 0 plus 2 will give me plus 2. 2 plus 2 plus 0 will give me plus 2. Hence, I end my solids. So we have, what we have? We have, it is atomically balanced and ionically what? Balanced. So the solution is actually solved. Can we have one more example? But I will be very fast with that. I am just moving gradually so that you get it one. So I will just quickly solve one more example and we have it. So let me have one example there. I have iron plus, okay, iron plus bromine gas. All right. So we have, let's have example 2. Example 2. So what's the question? Iron 2 plus, right?
2 plus, yes, aqueous.
Plus
bromine 2
plus bromine gas,
yes,
right?
To give us iron aqueous 3 plus.
Okay, iron 3 plus aqueous.
Plus bromine minus aqueous.
That's bromine ion. We call it bromine ion. Does that make sense? Right. So I have this question. To solve it using the half cell equation, I want to change I have to do gradually. So I have Fe 2 plus aqueous, right? To have Fe 3 plus aqueous, then the other side I have bromine gas, right, to give you bromine aqueous, bromine ion, right? So what am I to do? I'm to balance it atomically first. But before that, where is my oxidation half and where is my reduction half? So this is oxidation because the value of this is increasing. Hence, there is a loss of electrons. So I have oxidation. Oxidation half cell. So this is, the value is moving from 0 to what? Negative. Hence, it is losing electron. It is gaining electron, right? And gain of electron is called what? Reduction. So I have reduction half cell. So having done that, let me check if it is atomically balanced and ionically balanced. So atomically, I have Fe here, it is still 1, 1. One atom of iron, one atom of, forget about the charge, I said that earlier. One atom of iron, one atom of iron here. 2 atoms of bromine here. But there is 1 atom of bromine here. So I have to increase this to 2. So I want to check it if it is atomic and ionically balanced now. This is 2 plus, this is plus 3. This is 0. The charge is 0, the charge is negative. So let me balance this first. I have plus 2, plus 3. So what will I do? Can I increase this to plus 3? Yes. Okay, let me take the other way around so that you know that it is not compulsory you add it here or you subtract it here at the reactant side. Does that make sense? Let me do it from this angle now. I want to reduce the value to be what? Plus 2. So you have plus 1e minus. Have I subtracted? Yes. Minus times this will give me minus 1. But plus 3 minus 1 is giving me what? It's giving me plus 2. Hence, I have balanced this ionically. So I can now clean these charges. Does that make sense? Can I balance this from any angle? Yes. I have 0 minus times 2 here will give me minus 2 and this place 0. So how can I make this minus 2? By just saying plus 2e minus. Plus 2e minus, what will I have? I will have minus times this times minus times plus 2 give me minus 2. 0 plus this will give me minus 2 minus 2. Hence it is ionically balanced. So having done that, I don't need this charge I added to the equation. I'll just do what? I'll just multiply the charges. The charge of the coefficient of electron here times the coefficient of times this reaction, the coefficient of this times this reaction. So can we do that now? So I have multiply oxidation half, oxidation with 2 or by 2, right? And reduction half by what? By 1. Yes or yes? So we have this done. I can now say Fe 2 plus. I'm multiplying by 2, so I can say times 2. This is telling me times 1. Does that make sense? So I can say 2 times this will give me 2Fe 2 plus to give me 2Fe 3 plus 2e minus. This is my equation 1. I have multiplied by 2 to repeat the reaction since 1 will not have effect on it. So I have 2e minus to give me 2Br minus aqueous, right? Then I have my equation 2. So what am I to do? I am just to add up the 2 equations. So I can say add up equation what? 1 and 2. So how am I going to add up the reactant and the reactant, the product and the product? So I have 2Fe, 2 plus Br2 plus E2E minus to give you 2Fe 3 plus 2E minus plus 2Br minus aqueous, right? Since I have that, can I cancel the charges? Yes, the charges will be cancelled. So what am I left with? 2 ion with a charge of 3 plus Br gas, right? This is a gas, please. Yeah, I have aqueous here, right? So since I have aqueous here, right? So I can now have 2Fe 3 plus aqueous, right, plus 2Br minus aqueous. So what's remaining to check if it is atomically and ionically balanced? Atomically. 2Fe is here, 2Fe is present here, 2 bromine, 1 times 1 invisible 1 times 2 will give me 2. 2 bromine here, invisible 1 here. 1 times 2 will give me, so it is atomically balanced. Now, ionically now, plus 3 times 2 will give me plus 6. This is having no charge, 0 times 1 is still 0. Plus 3 times 2 will give me plus 6. Minus times 2 will give me minus 2. Right? Will give me minus 2. Hence, something is wrong somewhere. Something is wrong somewhere. So let's see where the problem is coming from. Let's see where the problem is coming from. We have 2 plus. So I want to trace the problem from this side. I'm multiplying this by 2. I'm multiplying this by 1. Right? Minus 2 minus 2. 2 times by 1. 2Fe 2, correct. Now 1 and 2, I have 2Fe plus Br plus this, alright. Okay, this is 2 plus, right? So I have plus 4, hence plus 6 minus this will give me plus 4. This plus this is giving me plus. So I know that my answer is what? Correct. So in our next class, we shall be looking at balancing the complex equations which involves oxygen. As I've said before I started the class, I said when you have questions involving oxygen atom, it is a complex equation and we can be asked to balance it in acidic or you balance it in what? Alkaline medium. I hope this solves some minor issues and I will see you next time.